This is section 7.4. This is part 2, adding and subtracting rational expressions. We've done a bunch where we had a common denominator. Now we have different denominators. So our first step is to find our LCD. Here we just have numbers. So I take my larger number, which is 5. 5 times 1 is 5. 3 does not go into 5. 5 times 2 would be 10. 3 does not divide into 10. So we keep going. 5 times 3 is 15. And that is the first number that both of them divide evenly into. So my LCD is 15. So I need to rewrite this. I'm dropping down here on a diagonal as something over 15 plus something over 15. In the last section, we talked about rewriting fractions with different denominators. And what we do is we ask ourselves, what did you multiply this by to turn it into this? 5 times 3 is 15. So I need to multiply the top by a 3 as well to get 3z. Now from here to here, I multiply the 3 by a 5. So I need to multiply the top by a 5 as well. So that is 5. Now they have a common denominator. Now we can add them. 3z plus 5 over 15. Now we need to see if this reduces at all. And we would look to see if the top factors, there's no GCF here. It doesn't have a square on it. That would have to cancel out as a unit or not at all. And so I cannot cancel out the 5 and the 15. I cannot cancel out the 3 and the 15. This whole thing is your answer. Okay, so let's try this problem. 10 over 9 minus z over 3. What we want to do is we want to find our LCD, which would be, start off with largest, which is 9. 9 times 1. 3 does divide into 9, so my LCD is 9. So I need to rewrite this as something over 9 minus something over 9. Well, that already is a 9, so the 10 doesn't change either. To turn the 3 into a 9, I multiply that by a 3. So multiply top and bottom by a 3. And I get 3z. Now I can subtract across the top. (10 minus 3z over 9). I would check to see if this factors. I do not have a GCF. I don't have a square. Nothing here factors. This would have to cancel out completely as a unit, but it doesn't. So this whole thing is your answer. Okay. So let's try this one. This time we have an x in the denominator. We just have to make sure that it's taken care of in our LCD. We have to find that first. I have 5 and 3 again. We dealt with that one 2 problems ago. My LCD for that part, the 5 and the 3, was a 15. Now we look at our variables. I have an x base, so I need an x base. The 3 is taken care of in the 15. This x is here. My largest exponent that appears on an x is a 1 because it's a 1 in both of them. So my LCD is 15x. So I want to rewrite this as something over 15x plus something over 15x. To go from this denominator to this one, I multiplied by a 3. So I need to multiply this entire numerator by a 3 as well. Here to here, I multiplied by a 5. So I'm going to need to put this in parentheses and multiply it by a 5 as well. So before I distribute, I have this. Okay, I need to extend my fraction bar. You always want to make sure it's long enough. Okay, now I need to simplify this. Well, let's go ahead and combine it into one fraction first. They can go in the same numerator. It's all over 15x. Now distribute. And coming back over here, I get 3x plus 6 plus 30x plus 15. And this is all over 15x. Okay, let's combine like terms. 3x plus 30x would be 33x. 6 plus 15 would be 21. And this is over 15x. Okay, so it's added now. Now I need to get it in lowest terms if possible. I look at the numerator and I see that I can factor out a 3. If I factor out a 3, I get 11x plus 7 over 15x. And now that it is factored, I can reduce the 3 and the 15. If I divide that by 3, I get a 1. Divide this by 3, I get a 5. So my answer will be 11x plus 7 over 5x. And that's as good as that gets.